Hello and welcome to our lesson on rates of reaction, looking at the shape of a reaction graph. So the first core concept I just want to reintroduce you to is this idea that a chemical reaction makes something new. So we have reactants and they make a product. So particles on the reactant side are the reacting particles and particles on the product side are the product. And chemical reactions are difficult to reverse. So without any further knowledge, I'd like you to pause the video and describe the shape of the graph. Okay, well, describe means say what you see. And with no knowledge of this topic at all, you should be able to very easily say, well, I have a steep line here, it's shallower here, it's curving here, and then it flattens out here. And that is the description. There's no need for a reason why that's happening. That's not what this question is asking. Describe the shape of the graph. The good news is this shape is the same shape for all chemical reactions. It always starts off steep, it always curves into a shallow line, and then it always flattens out. The bigger question is, why does that happen? So let's consider chemical reactions. They take place when reactant particles collide with each other and form new products. So they're going to be wandering around. We know particles move and they're going to move around and they're going to collide with each other to form something new. Now, not all collisions are successful. And if we want a reaction to take place, then we have to have a successful collision. So what makes a successful collision? Well, collision theory, it's a very posh word of saying it's our ideas about particles bumping into each other, explains that chemical reactions can only occur when reacting particles collide with enough energy to break any existing bonds and to make new bonds. We've got to make something new. So these particles just gently tap into each other. Nothing's going to happen. They've got to collide with enough energy that something will actually happen. And this is going to require some energy. And some chemicals will require a little bit of energy and some chemical reactions will require a lot of energy. The minimum amount of energy any collision needs is called its activation energy. And you should remember that from looking at energetics and endothermic, exothermic reactions. So our core concepts then, collision theory, simply talking about particles successfully colliding to break and make bonds, and activation energy, the minimum energy needed to start a reaction. Okay, so let's look at this graph again, because this is the point of this lesson. I'm telling you all reactions are very predictable. We know they have a beginning, and we know that's going to be fast. That's why it's got a steep line. We know that we have a middle where it curves round, which means the reaction is slower. And we have an end, which is when it flatlines and the reaction has stopped. So if we're talking about the rate of reaction or the speed of a reaction, or whether a reaction is slow or whether a reaction is quick, we are talking about the number of successful collisions per second. In 1 second, how many collisions were there and were they successful? So if I had a few successful collisions in a second, so I have a low frequency, you would say that reaction is slow. However, if I had many successful collisions in a second, a high frequency of collisions, you would say it's a fast reaction. So the core concept here is you need to be talking about frequent successful collisions, more frequent successful collisions, less frequent successful collisions, no frequent successful collisions, what is happening and how often are they happening. So let's build upon this idea. Let's just pause the video and have a go at describing the graph for each of these points. Okay, well, hopefully you said A is steep and therefore you would say it's a fast reaction. You might say it's less steep here or it's shallow here, so we've got a slower reaction. And again, the ones in brackets really are more explanation, but I've included them anyway for now. Here, it's still working, we still have a reaction, but it's a very shallow line now, isn't it? So we've got an even slower reaction. And here, and you'll notice at this point here, not at the end of, if I can just bring that in here, this point here is where the reaction finishes. Not here, I'm still recording here, but I'm not making any more, and I haven't made any more since about here. So this is where my reaction actually stops. Be careful. And it's a flat line, which means we're stopped. What I'd now like you to do then is explain the stages of the graph using this idea of frequent successful collisions. Okay, so we started off with the steep and the fast reaction. So why is that? Well, it's because we have many successful collisions per second, or a high frequency of successful collisions, or lots of frequent successful collisions, something like that. But as long as you've got that idea. Here we have a less steep line, so we have a slower reaction. Why is that? Well, we are having fewer successful collisions per second, or a lower rate of frequent successful collisions, or less frequent successful collisions. This one here, it's even more shallow, so it's even slower. It is still reacting, we are still getting some collisions, but they are less per second. And here we have a flat line, which means the reaction stopped. Why is the reaction stopped? Well, because there's no successful collisions per second. Why is there no successful collisions per second? Well, I've run out of reactants, haven't I? So this makes sense if you think about it at the beginning. Where am I? Sorry, here at the beginning, I've got lots of reactants. So they're all going to be able to collide with each other relatively often. It's going to be really easy to find something to react with. Over here, especially towards the green one, they're going to be colliding, but they're probably colliding mostly with other products now. So it's going to be really difficult to find another reactant left over to actually react with. So it's going to take a wee while. It's going to be a bit slower. And here, I've got no reaction left. I might have some reactants left, but unless I've got both reactants left over, my reactant's going to stop. My reaction's going to stop because I've got nothing colliding successfully. I've got nothing left to make new product with, and so it stops. Okay, so what are the key points I want you to take away from this lesson? Well, first of all, reactions occur when atoms collide with enough energy to break any existing bonds and to make new bonds. And these are called successful collisions. If you're not talking about successful collisions, you will not get the mark. All reactions follow the same trend where the reaction is fast at the beginning, then it slows down, and then it stops. There you go. And this is because the longer the reaction continues, the longer it takes any remaining atoms to find something to react with. Okay, that's it for this lesson, guys. I'll see you later.